Alright, so I've done experiments like this before, leading up to my cement battery idea. I gathered a bunch of ideas off the internet, things I've watched. I just want to confirm things with myself. And I like things that you could just do within an hour and you have your proof. This one was one of the videos that kind of got me started on the idea, and it was just too too it seemed too comedic or too simple to to be true. When I saw a guy, he had like a pipe, one of those donut cake molds or whatever that you bake in, and he had a bunch of rocks in it, and then he had a multimeter, and he was like getting some readings off of it, and I was like, what the heck? That's got to be a hoax. And I but it was so simple. I'm like, well, let me just try similar things. I actually never tried that, but I want to try it now. And this and now I'm thinking, oh, that's got to be true. That's I've already proved other things to myself. There's energy in everything, in the air, in the ground. This is related to an earth battery type of thing. There's a lot of quartz in these rocks. David Hutchison, I believe John Hutchison, he made a flashlight out of crystal wafers, stuff like that. So I did research in knowing that you can extract electricity from almost nearly everything. I mean, and just to figure it out, a multimeter, you just if it reads just a little bit, you can get some knowledge of where else you can go with it. You can get better materials, better metals. I found basically this stainless steel bowl with a stainless steel sifter thing, and I and if you have two metals, and then you have a material in between, there's you could test them out. You just have a multimeter, you just test it. So a multimeter is so informative, and I'm just going to do this basic test and then just get the concept, because then you can take off on your own with your own ideas. So basically, I just found some rocks in my front yard, and you can't have the two metals touching or else it'll zero it out. It'll short it out. So just pretty simple. Rocks in a bowl. And so I just pay attention to the multimeter when I just put it on different things, and see already it jumped to zero point 0.1 volts, 0.07 volts. So, and you could hold it there and just kind of see where it levels out, and then it always kind of has a drain on it a little bit. Goes down just a little bit, and then as you take it off, let it sit for a second and then put it back on, it jumps right back up. So it has a recovery factor. And this concept is so simple, and this is basically just one idea of doing it, but it led me up to other concepts of what to do. Like one of the ideas is to how can I make better materials? How small can I get with the same reading or more power? What better metals can I use? Sorry, I said that. What other materials can I use as in between the metals? Stuff like that. And the basic idea is the more surface area on the metal, the better. And so you can get smaller. I used a aluminum can before to make my aluminum dirt batteries or sand batteries. Some people have used sand, have some sand in there, and they just put it inside an aluminum can with like a copper coil inside. You can get some copper from anywhere, and just kind of coil it up in there, and then put inside the can, and basically you've got your two metals. In fact, I could probably just put this coil of wire in the rocks, and you can just experiment with different ideas. So this is just pretty funny how it's just a simple idea, just to demonstrate the concept. I probably won't get much out of that, but you could kind of just see what you can do. See, it's registering very little, but you can kind of hold it on there and see where it goes. Place the leads in different areas, but it's getting something. So say you want to try different ideas, like burying it in more rocks or putting sand all over it, because sand is basically just the same as rocks, just more surface area to work with, and that's a good idea. And then maybe extending this copper of wire a little higher, so it has kind of an antenna type of effect, and so maybe frequencies get to that, and then it has a higher reading or something. I don't know. Look at that, it did it. See, those are just ideas I'm having right off the cuff, and I'm thinking, oh, it's having a result. You take it off and then put it back on. Right before it was down 0.008, and now it's like doubled that, just from extending this as kind of an antenna. So you can kind of get a concept of like an earth battery, of what you can do there. People make those all the time. They stick maybe a couple metal rods in the ground, and then they do a reading on both of those. But you can kind of see maybe where Tesla was getting his concept of, there's electricity everywhere, in the air, in the ground, frequencies, and all over the earth. The earth itself is a big north and south pole, electromagnetic sphere. And so you get all these electrons going, and basically you just have to get it to flow through everything. And the two metals kind of help the electrons move through the material and pull to one side or the other, the negative or positive. So in fact, you can get even smaller, and this is a tea light that I took out the candle wax and stuff, and I melted it a little bit, so because the wax would prevent the surface area. There still is a little bit of wax in there, but I'm just going to try it and say that I got some sand. And so I put it inside there. And so now this is kind of like a smaller version of what I just did with this bigger bowl. And let me find, so here's some copper tubing. This is a cap, and I just have that in my little bag of tricks. And so you just put that there and the other metal on top of there, and then you could just experiment and see what that does. And in fact, I'll hopefully I could rearrange this. I don't have the best tripod. Okay, so I'll put it on top of this, so it'll, because this table is made of metal too, so it's not going to help. So I'm going to put that on top of this plastic container, and then I'll just do a reading off of it. And if you haven't seen my cement battery, is basically this concept. made like 12 of them stacked up and put inside a PVC pipe, and I had a flashlight. So it was pretty cool. And this is kind of like a aluminum can sand battery, and you get a bunch of people experimenting with that kind of concept. The kids are doing it now too. So here's the concept, and we'll just see if it has a reading, and if it has any kind of jump or whatever, it'll tell you something. So if there's nothing, there's nothing. You try something else, and I know there's wax on the surface of some of that. You kind of have to mess around with it. Some of those jumps don't really mean a lot. You just got to get something consistent. I don't know, maybe a little bit. But I know that surface area isn't the best. Then you could try the things like maybe moisture. Maybe that'll help. So let me try to get some water in that. So this is just regular tap water. And I'm already confident that this helps. I mean, it just, in a lot of batteries, they use water. I mean, you already seen that before. I was going to dump over. All right. So I'm already confident that it'll at least get something, because the surface area and is better. There you go. Look at that. So it goes up to 0.6, almost 0.7, but 0.60. You can hold it on there for a little bit. 0.5. But that's an obvious jump. That's one of those that you can see it really happening. And then, but you could experiment with different ideas, like taking two pipes into the ground, and you've got kind of an earth battery concept there. And if you do multiple cells or multiple poles, hook them all in series, and then that'll multiply the volts, and you got your. That's pretty consistent. So the moisture definitely helps, and you've got the outside conditions. Whenever it rains, it'll definitely help it. You know, if you have an earth battery. If you have, I thought of an idea of having a mobile one where you're camping, you stick it into the ground, and if you have extra water that, like from your gray tank, and it just kind of dumps water on the ground around it, it'll keep it moist, and then it'll keep your battery going pretty good. If it rains during your camp out, it's even better. So this concept is really fun to just kind of experiment with and take off on your own ideas. This concept got me further into other understanding of what to do. Better materials, better metals to work with, and the in-between materials. So if you get thinner and thinner and thinner and more surface area, you'll get the same readings and even better efficiency with the battery. So other people have used graphite as a material instead of sand, or other kind of crystal type of stuff like alum, and there's other stuff I can't remember. But then they put it inside, they let it crystallize between the two metals, and it just becomes a really, really powerful one. That's what John Hutchison did. You can make your own batteries that way. They have a strong voltage, and so it led me to. Let me go grab it real quick. So this whole logic and these little tests led me to graphite. So I started thinking of graphite because graphite has a very it's got a special property where it kind of acts like a metal, where it's conductive with electricity, but it also acts like a mineral where it can hold a charge, kind of like the sand. So it kind of has both properties, and you don't have to try to get the adherence to the metal, so it has a better contact with the positive and negative and plates, and you have a better material to work with. And then if you want to go a step further, you can get it into graphene, graphene is kind of like the refined graphite. Graphene is essentially one molecule thick. So that is like the finest you can get. One molecule thick. Oh, sorry. Between the two plates. And that's why graphene is so... people are talking about that a lot more. And that's why it's taking over... it can take over the battery industry. Because that graphene is so thin, you can make the cells so small and then stack them all up in series and have just a small unit with a very strong voltage, and then you can keep stacking them up. And they have a property where it'll hold a charge, but it'll also recover itself a little bit. And so it's a great material to work with, and probably the most efficient material that I've seen so far with these batteries. And so that led me to this guy that makes these graphene supercap module. That's quantum mechanics, and I'll put a link down below with this. But basically, they make supercapacitors made of graphene, and capacitors are all over in computer things. They're kind of like a temporary battery that'll hold a charge real quick, and then it'll discharge real quick. So it has that ability to do that, and they're all over in computers. And so they make like supercap batteries or capacitors that hold a lot more voltage or a lot more charge, a lot more voltage. And so that's where this comes in. There's several of those supercapacitors inside this thing. And so the benefits that you get from this is that you get a very quick charge with this. So that has a lot more capability of getting charged up even on a cloudy day with solar, where I was thinking even making earth batteries or your own little battery there, and it'll trickle charge it a lot faster even at night. So even with a small source, you get something, and this will be able to handle it, and meaning the small trickle, and it'll just charge it. And I've already proven this. I've taken in one of my videos, I took a capacitor off of a computer board like this. I zeroed it out, and I took my little a battery that I made from it was like from cement or something, multi-celled, and then I took my capacitor that was zeroed out, and I put it on the two leads on that battery I made for like 15 seconds, and it charged it like 8 volts or something like that. I can't remember, but you'll have to watch the video exactly what happened there. But so I know that works just from like a little battery cells that I made myself. Within a short amount of time, it charged a capacitor. And so that concept can be applied to a bigger cell or a bigger battery bank, and from a small source you could just trickle charge it and it'll work. So this says 16 volts, but you treat it as if it's like a 12-volt battery, and I think he made it 16 volts so it has that grace voltage, I guess. But right now it's 14 volts. But I've hooked this up to a solar panel, a smaller solar panel. Maybe I'll share that with you. But this there's a lot of potential here, and I love it that all we have to do is find a source of power which is everywhere. So you just got to figure out exactly how you'd want to do that. So get a multimeter, get all these ideas going, try these different ideas, and you'll be on a track to excitement. And my next idea is to get like a transformer. Like these boards also have transformers in it. Here's one, here's one, here's a toroid, kind of like a transformer, where it either steps up or steps down the volts, whatever they're wanting to do within the circuit. And so these can come in handy. Microwaves have them, but you can find them everywhere. And so what I want to do next is try to, I want to take one of these, take a small source of power that I made, earth battery or whatever, and see if I can multiply the volts from a transformer. And Tesla coil is essentially a transformer. It multiplies the volts, and we see that in ignition coils and engines and cars and motorcycles. To multiply the volts from a 12-volt battery to like 20,000 volts, so the spark plug can arc that spark and then spark the fuel that's in it. So all this technology is here right in front of us. I'm just trying to show ways and ideas that we can just kind of tweak it into the most efficient, the awesomest thing that we can have just within the reach of our backyard and in our box of junk. Alright, so I thought for the heck of it, I'm just going to try this, see if I could charge this capacitor. I just ended up taking it off the circuit board just so I could do a demonstration. And this is the battery that I just made, and I still have, let's see if I can set it up so you see everything. So I still have 0.8, goes down to 0.7 sometimes. So there's some voltage activity coming out of that battery still. And this capacitor, I've already zeroed it out, so it's got a positive negative terminal on there, and let's see, so it should read 0 because I zeroed it out. Basically you just connect the two terminals to short it out, and then it'll drain the capacitor to 0. So that's what I did. So it reads 0. Now I'm just gonna see if I can connect this to this just temporarily, and we'll see what happens. If it charges it even just a little bit. That's all we're looking for. Just a tiny trickle charge into this. We'll put it in for like maybe 15 seconds, and then we'll see how much it charges it up, if at all. Alright, I have a couple of these wires. I don't know if they're going to work better. I may not get a full connection here. This will be kind of hard to set up. So just kind of bear with me for a second. So positive, negative sides. Alright, so you saw, hopefully you saw that. Alright, so these wires will help, it'll extend it to my little capacitor. And let me zero it out just for good measure. Let's make sure it's 0. Alright, so that capacitor is zeroed out. Okay, so now I just have to get these wires. I have to make sure they're the right polarity, or else. Alright, so that's going to be top positive. So the top of that, the top of my homemade battery is positive, bottom is negative, and find the right terminal for positive on the capacitor and negative. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Alright. I don't know how good the connection was on that, but if this is charged just a little bit, then that is amazing. So let's just see what happens. If we get nothing, we get nothing. We try it again. There it is. 0.0466 volts out of that capacitor. Isn't that amazing? And they'll discharge pretty quick. Okay, I just want to try that again, just so it's not a fluke. And that's, I guess, how experiments go, if you could repeat it. But even just a little bit, even if it registered just a little bit, it's information that you can go off of, gives you direction and more ideas. So let's see, I zeroed it out again. Absolutely 0. Let's try where'd my wire go? Okay. Just try repeating the process. Just for fun. This is how you do it. Okay, positive, positive. Make sure this is all together. In the future, I'll have better testing things going on. Alright. Positive on positive. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Alright. This time I'll hold it on there, see if it'll... Positive on positive. Boom. 0.476 volts. I'm just going to hold it on there. .474, 3, 2. So you can see it's like discharging a little bit. 1. 0. I'm going to take it off. Put it on again, see what happens. Yep. 0.47069. 6.8. So that's kind of stabilized, and you can see the consistency with what the numbers are doing. Take it off for a second, put it back on. Yeah. So this time it held the charge. So I'm going to short it out again. And it will drain it to 0. So it's down to 0. Pretty much. So you can see what I'm doing with that, and you can just kind of keep going with that, but it's each time you do it, it'll confirm, or if it's not working, try something else. It'll give you direction of what to do. So it's zeroed out again. And just for good measure, I'm going to just try it again, just to see if the consistency is continuing. And so I was already confident it was going to do something. As long as I have a battery that registers some kind of voltage in there, then that voltage is going to transfer over. And that concept, you could just get imaginative of what the potential of this is going to be. Especially with my, on a bigger scale, bigger version of that, earth battery, and then to a bigger battery bank, and you could buy multiple capacitors like this, modules, stack them all up, and this has like 73 or 75 watt hours, but you could stack them up, get about 6 or 7 of them, and have a good, it'll be like a marine battery. So I just want to try this one more time. Just because I'm excited that something's happening, and something's going on here, and it gives me some excitement for other ideas. Positive on positive. And 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. 15 seconds on that, and then positive on positive. Boom. 0.455. 0.454. Just doing the same thing as it did last time. Just discharging a little bit. So there you go. There's the concept. Just try this yourself. Do your own experiments. Go off with your own ideas. This is pretty awesome. I mean, the potential in this, it's amazing. I bet even my first experiment with this bowl, getting a little bit of that little registry of volts in there, even charging a little capacitor battery. So the concept works. It's just putting it to a practical, usable concept on a bigger scale, multiplying volts. I got this these little transformers I'm gonna try using, multiplying volts. See if I can get some things lit up or charging a cell phone or something like that. That's the goal.